Welcome back to my channel. In this video we are going to discuss about resting potential. The cell membranes are having potentials. Two potentials are created in the cell membrane. One is resting potential and another one is the action potential. Here we will discuss about the resting potential. The ions will be moving from the inside to outside and outside to inside of the cell. This movement is happened due to drift and diffusion process. Because of this process, the balance of ions, it will rise to balance of ions between inside and outside of a cell, and due to the difference in permeability of the different ions, charge balance is not achieved, so that equilibrium condition is reached with the potential difference across the membrane. So the negative potential is inside. We can see here the ions are moving here and there. Finally, the more number of negative ions are present inside the cell and positive is outside. So the resting potential can be defined as the membrane potential caused by different concentration of ions. Okay, the membrane potential caused by different concentration of ions. And we can say thus, when the human cell is in the resting stage, it is said to be polarized. So we can see here the resting potential is, it is the negative potential, because in the inside of the cell only we are going to measure with reference to the outside. So the measuring electrode we are going to place inside, so the resting potential is negative. So the characteristics of the resting potential. So the value of the resting potential is maintained as a constant until some disturbance upsets the equilibrium. Otherwise, the constant potential will be maintained at all the times. It strongly depends on the temperature. The permeability of the different cells varies. The permeability varies. So what happens means the correspondingly the resting potential also varies. So if you see the ranging of the resting potential is minus 60 millivolts to minus 100 millivolts. Usually we can, for a nerve cell it will be minus 80 millivolts. So as I said, the resting potential is in the negative. So we have to mention like this, minus 60 millivolts to minus 100 millivolts. And the next thing is the resting potential is developed by the Boltzmann equations. So we can see here, this is the equation given for the resting potential. E equal to kT by Q ln Pk K0 plus Pna Na0 plus Pcl Cli divided by Pk K of I plus Pna Na of I plus Pcl Cl0. So here K is Boltzmann constant, T is absolute temperature, Q is charge of electron, and Pk is, that is permeability of the potassium ion. So Pna is permeability of the sodium ion, Pcl is permeability of the chlorine, and K of naught is, that is concentration of the potassium ions outside. O indicates outside, I indicates I. So this is the way the resting potential is given by Boltzmann equation. According to the Boltzmann equation, the resting potential for the nerve cells is minus 86.8 millivolt. And furthermore, this equation is reduced by the Nernst. So when we consider, that is the permeability of the sodium and permeability of the Cl is negligible compared to the permeability of the potassium. So Pna and Pcl is almost equal to 0 when compared to Pk. So we are going to consider only Pk. So if we consider Pk, the remaining two terms will be cancelled. So here we are going to have only this term alone. We are going to have Pk we can cancel. So we will have the equation is minus Kt by Q ln K0 by Ki. Concentration of potassium outside divided by concentration of potassium inside. So this is the equation given for the resting potential. So if you see here, that is the simulations, this is the way it will be happen. The resting potential is present in the cell due to drift and diffusion. So when we give some excitation, the action potential will be developed. After the action potential, again it will come back to resting potential. This is like a cycling process. Resting potential, if we give some excitation, because of the excitation the action potential will be developed, but the cell won't stay for long time in the action potential stage. Again it will come back to the resting potentials. So this is what happening here. So resting potential is nothing but a membrane potential. This is due to drift and diffusion process of ions. So it is a negative potential. It's around minus 860 millivolts to minus 100 millivolts. The next video we will discuss about action potential. Thank you.